Okay, we have now here an integral which is improper of the first kind, right? Because there's an upper limit which is infinity. There's no problem at this extreme here because the arctangent and this function here are well behaved in any positive interval starting at 1, right? The only problem would be at 0, but 0 is not included in this interval, so there's no problem at all. So it's only an improper integral of the first kind, right? What we're going to do now is to get to use the Taylor expansion of the arctangent in order to figure out what is the behavior of this whole function, this whole integral, which is complicated, at infinity. So when x goes to infinity, the argument of the arctangent, this one, goes to 0. So what we need is the behavior of the arctangent when the argument of the arctangent goes to 0. And we know that this is t minus t cubed divided by 3 plus ot cubed when t goes to 0. So if we substitute t by 1 over square root x, what we have is that the arctangent of 1 over square root x is equal to 1 over square root x minus 1 over 3 x to 3 half plus 1 over x to 3 half when x goes to infinity, because when x goes to infinity, the argument of the arctangent goes to 0, which is when this expansion is valid. All right? Okay, so we have this expansion for the arctangent of 1 over square root x. We subtract this and this minus the arctangent, so we have 1 over square root x minus the arctangent of 1 over square root x is equal to, this cancels with this, and what we have is 1 over 3 x to 3 half plus 1 over x to 3 half, which means, this is when x goes to infinity, which means that in this limit, this function f, which is the integrand that we have to analyze, simply behaves as 1 over 3 x to 3 half, okay, when x goes to infinity. So whether this integral converges or not depends on whether the integral of this function here converges or not. And that is easy to decide because the integral from 1 to infinity of dx over x to 3 half is convergent because the exponent here is larger than 1. So the integral that we're analyzing, this one, is a convergent integral.